Today we are working all on factoring. So we're going to be starting off with the difference of two squares. The difference is referring to the subtraction. So just another way to say subtract. So the difference between two perfect squares, so doubles of these values. You'll notice that these two or these values or these expanded forms are missing their third term. So the middle term is missing. And the reason for that is that when we alternate your signs, if we were to FOIL these back out, the middle two terms, so a times -6 and +6 times a, will then negate each other. So that's why your middle term is going to be missing, because on each and every one, it's going to negate. So when we tackle these, the first thing to note is that we're making sure that all of these have a subtraction sign and these two terms. So notice that this one is not a subtraction sign. So this one is not going to be factorable. It's going to be considered prime. And even more, it is going to not be considered that perfect difference of squares because of the addition. Now, to recognize a difference of two squares, we need to have all of your terms being a square. So looking at this first x, right? X squared is just telling us that we have two x's here. And if we rewrite your 1 to show that it's a square is a number times itself. So 1 times 1 can be 1 squared. So this 1 is really 1 squared. And again, there's two of them here. And when we go to factor, right, we talked about changing and alternating your signs so that the middle sign, the middle term, is not present. So we can say plus and minus. Now, if we were to FOIL these back out, you'll notice that your first term being the x squared, and then your x times 1 is x plus 1. And then the next term, let's see. Oh, I did that very weird. We have a negative x, and then the last term, we have -1. So those middle two terms are going to negate each other out. So you're left with x squared minus 1, which is our original starting one. So to factor it, all you're doing is two values, or showing that you have two of something and then negating your signs or alternating your signs. Now, I know 2 is not listed, but let's go ahead and try that one again. So again, to fall into the difference of squares, we're looking at subtraction. Now your x is already squared, is already showing the exponent of 2. Now let's do 9. So what number times itself can get you to 9? Well, 3 squared, right? 3 times 3 is 9. So there are two x's and two 3's, and we alternate your signs, one positive and one negative. So your final answer is x plus 3 and x minus 3. Now let's do number 4 one more time, and then we'll get into some of your other ones. So we'll do 4. So we already have x squared. Now what number times itself will get you to 25? Well, 5 squared, 5 times 5 is 5, or 25. And you have 2 of these and 2 of these 5's, alternating your signs. So you're left with x plus 5 and x minus 5. Now let's get into what happens if you now have a coefficient attached to your variable. Notice that in these variations, we do not have a coefficient attached to them. So they have just been 1, which we talked just now about being a perfect square. Well, the approach is still the exact same. So what number times itself gets you to 9? What's 3 squared? Y is already squared. Now, what number times itself will get you to 16? We have 4 squared. So now we can just get to write out 2 of everything and alternate your signs. And there you go. 3x plus 4 and 3y minus 4. Now let's get into number 12. So number 12, the way that it's written is not a perfect square, or sorry, difference of squares. However, notice that your leading coefficient is negative, which we don't typically like factoring when we have a negative leading coefficient. So we're going to go ahead and factor out your negative and change all of the signs. So changing the sign from a plus sign to a minus sign. Now, does this, or I should say your parentheses, fit the category of a difference of squares? It does. So you do now have the subtraction sign. You have two terms that are now perfect squares. So see if you can pause the video and figure out this one. So negative is just going to follow and stay on the outside. So we have x plus 4 and x minus 4. And that negative sign just stays on the outside. Do not put it back in through your parentheses. Let's see. Let's try that again with number 9. Again, noticing that your leading coefficient here is negative. So if we were to rewrite it, it would look like this, very similar to what we just had. So factoring out the negative and switching your sign. Then we can say, well, we really have negative x plus 5 and x minus 5. All right, let's do another one. Let's do this one. So you have 16x to the 4th minus y squared. Now your first thought might be, okay, well, this isn't actually squared, so it doesn't fit that category, even though we have 4 squared and you have a minus sign and your y is squared. But 4 squared, based on your properties of exponent, or sorry, 4x to the 4th, we could actually rewrite 4 or x to the 4th as being x squared all squared. So when we distribute this back in, we are multiplying to get back to your original. So when we go to figure out, okay, well, this is your perfect square, we're writing these 2 4s and the 2 y's as we did before, but now you have these 2 x squares. So it's this x squared that we're going to be writing twice. So your final answer is 4x squared plus y and 4x squared minus y. So another good one to practice is number 21 as well, coming from that. So that is your difference of 2 squares problem. Now let's take a look at factoring perfect trinomials. So perfect trinomials, when we go to factor them, we can actually condense a little bit further because they come out as the exact same. So if we were to do this one out, we have 49, and this is simple factoring. So you're always looking for a GCF, so values that fit within all three, which there is no GCF. It is simple factoring because your leading coefficient here is 1. So looking at factors of 49 that can get you to a 14 would be 7 and 7. So 7 times 7 can get you to 49. And then we want to look at, okay, well, how can 7 and 7 make a negative 14? Well, it can make a negative 14 if we subtract both of these 7s. Now, simple factoring is nice because once you're done, all you have to do is write what your factors are. So we have your minus 7 and minus 7 to be right here. So they go right into your parentheses. But notice because they are the exact same, we then just get to write that there are 2 of them. So let's start again with number 1. We have x squared plus 8x plus 16. So let's look at factors of 16 that can get you to 8. Well, 16 is 1 is 16, 2 and 8 and 4 and 4. So looking at all of your factors, which ones will get you to an 8? 4 and 4 can get you to 8 as long as we add them to make positive 8. And if you multiply both positives, it will still get you to 16, a positive 16. So they can go right into your parentheses, these positive 4s, and even better, because there's 2 of them, we now just get to say there are double of them. Let's try it again with number 4. So 25 is 1 and 25, 5 and 5. And of these factors, how can I get to a negative 10? Well, 5 and 5 can get us to 10 as long as they are being subtracted. So it'll get us to negative 10. And when we multiply the two negatives together, they make a positive 25. So we have x minus 5 and x minus 5. There are those two minus 5s. And because they are the exact same, we can just put x minus 5 all squared. Let's have you try number 8. Actually, we just did number 8 from the above. Let's see. Another good one would be probably 16 and 17. I'll write those here for you. Oh, so sorry. This one is actually prime. Because factors of 4, 1 and 4, 2 and 2. Well, yes, if, well, actually, none of them can get you to a positive 2. So this is not factorable. Well, let's look at 17. So you have 1 and 1, and they can both make, if they're both positive, they can make a 2. And if you multiply them back together, they'll get you to 1. So we have x plus 1 squared. Now let's try number 7, because number 8 we already did, x minus 7 squared. So now let's take a look at this one. Now with this, we want to use, I mean, you can still use your perfect square trinomial. If you are recognizing that your first and your last term, cannot talk today, your first and your last term are perfect squares, and the middle is exactly double that amount. So if you're recognizing it, then great, that is the process. Otherwise, let's go ahead and do some of our other factoring methods. So I'll do one here. We'll call it the AC method. So A being 25, B being 10, and C being 1. It's called AC method, and these ABCs are just coming from the natural structure of your quadratic. So you'll notice that A is directly attached to your x squared term, B is attached to your x, and C is your constant. Now this AC method says we're going to multiply A times C, so 25 times 1, which equals 25. Now looking at factors of 25 that can get you to 10 would be 5 and 5. Now this is a positive 10, which means they both have to add to 10, or they're both adding. And when we multiply them back together, they still get us to 25. So now what we're going to do is we're going to write this positive 10x as 5x and 5x. So we have 25x squared plus 5x plus 5x plus 1. So we're just rewriting that middle term with what we found. Now we get to use factor by grouping. So grouping the first two and your last two, we can say this is really 25. Oops, so sorry. Grouping the first two and last two, we're looking at a GCF from your first two, which is a 5 and an x, leaving behind a 5x plus 1. So we're taking all of this, which means we have a placeholder. Now, if we like this 5x plus 1, because at the end of the day with factor by grouping, we definitely want a 5x plus 1 to match this one, because that's what we'll factor out. So if you like what you have already, you just get to factor out a positive 1. So now we get to factor out this 5x plus 1 from your terms on the outside, and you're left with 5x plus 1, which is from here. And then your two outside terms will come together as 5x plus 1. Now again, because they are the same, we are going to bring these together and square it. Let's try that again. Let's try 14, and then we'll try 11. So 14, we have 49, B we have negative 14, and C we have 1. So we're multiplying a times c, so 49 times 1, which is equal to 49. Factors of 49 to get us to their middle term of negative 14. We're looking at 7 and 7 as long as we both subtract them to get negative 14. And if we multiply them together, we get a positive 49, which is what we wanted. So we're going to rewrite that middle term as 2 negative 7x's. So this middle term here is your 7 and 7. There you go. Factoring out a GCF from both terms. So we have 7x in common. You're left with a 7x minus 1. And notice that on your next one, it looks very similar, but your signs are different. So let's go ahead and subtract out a negative x, or factor out a negative x. I'm so sorry, a negative 1. And that will then change the signs on the inside. So then we get to factor out our two parentheses, which are the exact same. And then it'll leave behind a 7x minus 1 that is from your middle term here. Because there are two of them, we get to just square the top. All right, last one. So here, again, looking at the process of this. So noticing that this is really 5 squared a squared. And this is really 6 squared. Now this is the middle term is really 2 times your first term, 5a, and your middle term, or in your last term, 6. So as long as that's true, so if these first two are squared and the last two are squared, in your middle term, let's see, 2 times 30a will then be 60a. We can go ahead and then just say, okay, well, if that is true, then we have 5a and a 6, and we have two of them, 5a, 6, 5a, 6. And because they're both all positive, we're just going to say now this middle is positive. We have 5a plus 6 squared. So this, you don't have to do that multiplication throughout unless you wanted to, like we did here. But sometimes if your numbers are really big, you might want to strategize and just make sense of what we've been doing, why they're that duplicate on the inside. So pulling out your first term here, your second term, or your last term, and then it is twice that amount. So if we wanted to do it again here, 25x squared plus 40x plus 16. You always want to go in descended order. It makes your life a lot easier. So again, this is 5 squared x squared, and this is 4 squared. So we're looking at 2 times your first term, 5x, times your last, 4. So we should get 2 times 20 to be 40. So again, that is true. So that means we do still have a perfect perfect square. So we have 5x plus 4 all squared. Okay, I think that's enough for that one. All right, let's take a look at factor by grouping. So we did a little bit of that method over here on 14 and number 7 here. So let's try it again with these ones. So factor by grouping happens when you have 4 terms. Now, before you get started with factor by grouping, you always want to double check if any of these 4, if they have anything in common. And if they do, we can go ahead and factor it out to start. Typically, that makes your life a little bit easier. Now, you'll notice that none of the 4 terms have anything in common with each other. So instead, we're just going to go right to group the first 2 and the last 2. And then we'll start to pull out a GCF. So noticing that this is really x squared as x and x, with a coefficient of 1. This 2 is really a 1 times 2 and just an x. Now, with your GCF, when we look at it, we're only going to be interested in factoring out what they have in common at most. So at most they share is one x value. So we're going to factor that x out. And what's left over is anything that didn't get highlighted. So this 1x and this 2 and the sign in the middle. So x plus 2. So on your next run, our ending parentheses, we're going to hope for an x plus 2. Now, if we don't, it's one of two things. Either it's not factorable, so it means it's prime, or it means that we made some human error. So again, one more time, let's take a look what they have in common. This is really an x times a y, or a 1 times x and a y, and this is really a 2 times a y. So one more time, we're going to highlight what they have in common. So we're going to pull out not just a y, but we want to pull out a sign with the y. Now, do we want to pull out a positive or a negative? Well, if they're both positive, we could just pull out the positive. If they're both negative, we want to pull out the negative. And if your leading term is negative, then we definitely want to pull out the negative. We typically do not leave negatives on the inside. So what's left over, we said, is this 1x plus 2. Now, as long as we did it correctly, these two parentheses should match. And on the outside, we have your GCF that we pulled out. So in the end, we're going to factor what your two terms in green have in common, which is this x plus 2. So you have x plus 2. And we're leaving behind those two in green, and x plus y. Let's try it again. Okay, let's try it again here. Again, we typically want to have this in a certain order. I won't rewrite it on this one, but typically we want to do it descended. So starting with your highest degree. So these two having a degree of 1, we can add them together to make a degree of 2. This one has a degree of 1. This is a degree of 1. S and T, so S comes before T, so it would go pretty much in this reverse order. But anyways, let's look. There's no GCF, so none of these have anything in common to start, so we can't pull anything out. However, we can take a look at your GCF from just your grouping. So notice that your 10 and 2, they do have a 2 in common. This is really a 1 times a 2 and 2 times a 5. So we can go ahead and take out a 2 from each. And that only has a t in it, which we are not factoring out that t. I just don't know where else to write it. There we go. So we're taking out a 2, and left over we have a 5 plus a 1t. Doing the same on the others. So this one we have a negative, and I'm going to write it as a negative 1 times a 5 times an s. This one is really a negative 1 times an s times a t. So highlighting what they have in common again, they have a negative 1 in common, and they have an s in common. So we're taking out a sign, which is a negative 1 s. And on the inside, we should have 5. And because we took out a negative, we now change it to a positive t. So your GCF's on the outside. So now we can go ahead and factor what we have in common. So we have this 5t, or 5 plus t in common. And on the inside, or on the outside, we have the 2s, or 2 minus s in common. Let's try it one more time with 11. Okay. So nothing in common with your first 4. So instead, let's group. We really have 1, 2, 3 y's and 1, 2 y's here. So at most we can highlight is 1, 2 y's from each. So let's go ahead and take out 2 y's, so y squared. and leaving behind a y, a minus, and then if we took out everything, our placeholder is still a 1, because keep in mind there's really a coefficient in front of these. So it's really just y minus the 1. Let's do it again on this next one. So what do they have in common? Well, they have a -1 times a 4 times y. This is really a 1 times a 4. So they definitely have a 4 in common. So let's just see what happens if you take out just a +4. You're left with -y plus 1. The plus sign and the 1 coming from here. Now notice, are these parentheses the exact same? No, but they are very close. It's just our sign that's a little different. So typically, if your negative leading term on this second one, if that is negative, we want to factor it out along with what your GCF is. This way we can then just alternate the sign on the inside. And then we can continue because they match. So you have y squared minus 4, y minus 1. Now, are we done factoring with this one? No, we're actually not done factoring because we have something special. Now, what is that special one? So y squared minus 4 is a difference of squares. We can write this as y minus 2, a y plus 2, and then your y minus 1 from the following. So that is just a little bit of grouping. Keep in mind, all you're doing is to start, check to see if any of your 4 terms, if they have something in common. If they don't, that's okay. And then grouping the first 2, grouping the last 2, and doing some GCF factoring. Now let's put it all together. So let's go ahead and see if you can pause the video and do at least these first few that are highlighted. Now you might be tempted to say on this first one that it's a difference of squares because you do have the minus sign, you do have this one as x squared. However, in this format, it's not a perfect square because 2 and 8 aren't perfect squares. However, do they have something in common? Well, this 2 and this 8, they both have a 2 in common. So we can at the very least factor out a 2 on the outside, and on the inside, we're left with a 1x squared minus a 4. Now we can say it is a difference of squares. We can say 2 on the outside, x plus 2, and x minus 2. Let's take a look at 3. All right, so before we get to start with factoring, what do they all have in common? So they all have a 3 in common, so we can go ahead and factor out your 3. So this is really 1 and 3, this is 3 and 3, and this is 3 and 10. So we're just taking away a 3 from both. So we have 3n minus 10. And now we can go ahead and factor. So looking for factors of 10, so 1 and 10, 2 and 5. Now of these factors, what can get us to a positive 3, but also when multiplied, keep the negative 10. So 2 and 5, as long as we are adding 5 and subtracting 2, that makes a positive 3. And if we multiply them back together, we still keep that negative 10. So we have your GCF on the outside that keeps following us through. And because this is simple factoring, we don't have any other number out front. We can just go ahead and put what we found into parentheses. Now, a great way to double check that we got it correct is just to FOIL it back in. So starting with your parentheses and then distribute your 3 first. All right, let's try number 4. So again, as much as you need to pause the video. So let's see, 6, 26, and 20. 26 is not immediately divisible by 6. However, it is divisible by 2. So let's break up all of your values by 2. So 2 times 3 2 times 13, oops, and 2 times 10. So we can factor out a 2 from each. So GCF is a 2, then we're left with 3x squared minus 13x minus 10. So now we can do a little bit of AC grouping. So we have A, B, and C. So we have 3, 13, and a negative 13. So sorry, and a negative 10. So AC grouping says we're looking for, can we move this over a little bit? Yeah. So A times C is 3 times negative 10 to make negative 30. So factors of negative 30, so we have 1 and 30, we have 2 and 15, and keep in mind we're going to get to negative 13, so the moment that you spot it, we can stop. So 2 and 15, as long as we are subtracting 15 and adding 2 to make negative 13, and we go ahead and multiply them back together to get a positive 30. So we can rewrite this as being 2 times 3x squared plus 2x minus 15. And the order doesn't matter if you want to write negative 15x first. Does not matter one bit. So then we can do factor by grouping. So you get 2 that's on the outside, and then you get x, 3x plus 2, negative, let's see, they have a 5 in common, 3x plus 2. So you're left with 2, x minus 5, and a 3x plus 2. Okay, let's do it again here. So looking at these values, we have 14, 7, and 21, all of which have a 7 in common. So we have 2x squared plus x minus 3. So again, a little bit of AC grouping. 2, 1, negative 3. So you have 2 times a negative 3 for negative 6. And we're looking at 2 and 3 to get a positive 1. So that's plus 3, negative 2. And when we multiply them back together, that does get you to a negative 6. So you have 7 x, I'm so sorry, 2x squared minus 2x plus 3x minus 3. So looking for your grouping, 7 on the outside, 2x, x minus 1, plus a 3 for, again, x minus 1. So you get 7, 2x plus 3, and an x minus 1. All right, one more time. For number 9, we have a GCF of 4. So you have x squared plus 4x plus 4. So we're looking at factors of 4, 1 and 4, 2 and 2. So 2 times 2 can make 4, but 2 plus 2 will also make a positive 4. So you get 4, x plus 2, and x plus 2, to then be 4, x plus 2 squared. All right, so your remaining ones, again, I'm hoping you're pausing the video and trying it out. Looking for your GCF, we have a 2x. We have 1 plus a y, or sorry, 1 minus y squared. So again, the structure of that looks a little funny. So let's go ahead and get the negative leading coefficient away. So negative 2x, y squared minus 1. We do have a difference of squares. And there you have it. One more time. T squared minus 9, 3t, t minus 3. There you go. All right, hopefully that video was helpful. This is all the different ways that we can factor. There's only one way that we did not cover, and that is factoring with difference and sum of cubes, but we'll do that in another video.